Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're going to be back working on the Monarch lathe, and it's finally time to start working on making a new bronze nut that will be used on the lead screw that powers the cross slide over there. So I've got my bronze nut here off of my lathe, and it's got a pretty significant amount of wear in it, so we're wanting to replace this. And while I'm at it, I've also got a second one. This is from a friend of mine, Neil Tyson, who lives up in North Alabama. He recently purchased a Monarch lathe, and his is also needing some work done to it, or needing to be replaced. And we got to looking at them and comparing notes, and it's pretty much the identical nut, with the exception of the holes up here in the top are a little bit laid out differently, but the nut itself is pretty much the same. So I'm actually going to be making two of these, two identical ones at the same time. Same basic dimensions, same thread pitch, everything else. The only difference will be the holes up here, and I'm going to let him drill his, so I won't even be worrying about that. We'll be focusing on mine, but just bear in mind I will be making two. So let me kind of zoom you in here, show you what we're working with, show you the game plan, and we'll get to start making this. So again, here's the lead screw that we're working off of that does the cross slide. Now this is kind of an oddball thread pitch. This is a 7/8 inch diameter, and it has 4 threads per inch, and these are full Acme threads. So it's not a standard 60-degree thread like you would normally use, but Acme. But what's unusual is that for a 7/8 inch diameter, you would usually have a more fine thread pitch than 4 threads per inch. 4 threads per inch is usually on a shaft that's on up there, I think 1.25 inches or larger in diameter. So it is a little bit unusual. The reason for the 4 threads per inch, though, is that every time you turn the handle 1 revolution, it's going to move it 1/4 inch, and with the calibration on the hand turning and all that on the lathe, that's really the pitch that they need for this. So, and they just didn't have room for that larger diameter. So hey, no big deal. If you're in the machine building business, you can spec out your parts however you want to. So the problem I'm running into, though, is that you just can't go out and find a tap that's 7/8 inch, 4 threads per inch. And oh, by the way, this is left-hand threads too. It's not right-hand threads, so it's a very unusual thread pitch. But you can't go buy a tap to tap a hole here. So we're going to be having a single point thread this on the lathe. Yeah, I could have had a tap custom built or even made my own tap, but for no more, just a couple of parts, we're going to single point thread it. It's just going to be the easiest thing to do. So again, this is my nut that we're going to be replacing. It is made out of brass or bronze. I'm going to be making the new one out of bronze. I'm not sure if this is brass or bronze. It really doesn't matter. Again, normally you turn it right hand to thread it on, but this one's left hand threads. But when you put this on there, I want you to notice how much slop we have in here. I mean, there's a fair amount of wear, and I've done some looking at this. You can come in here with my thread pitch gauge and actually check the threads on the lead screw. Very little wear on the lead screw in my situation. Almost all the wear is in the nut, and it's designed that way. This nut is made out of a softer material, brass or bronze, and it's made that way so that it will become the wear point, and this is basically replaceable. I'm sure I could call Monarch up and order one of these, and I'm sure it would probably also be $400, $500, $600, which is why I'm going to be making my own. Again, I have a machine shop. I can do it, so that's what I'm going to be doing. So that's what we're trying to get rid of. There's also a fair amount of lateral slop in here, so just a lot of movement in there, and we're trying to get this tightened up. We're going to restore this machine. Let's do it right. So as for the material we're going to be making the new one out of, again, this is a bronze material, and I actually ordered this from McMaster-Carr. You can order it right out of their catalog or online or what have you. Get it in different lengths. I think this is a 6-inch length, and they use this for all kinds of applications, including things like these nuts. They're used for bearings. They're used for all kinds of different things. This is an extruded product. That's why it has this kind of weird looking pattern on there, because it was actually extruded out of a die, and you can kind of see where those extrusion marks are. When you machine this and you take that outer cover off, it cleans completely up. I've used this material before for a project I did quite some time back. I'd have to go back and even try to find the video, but I do remember using it before. We're going to be, again, using it here. So first step that I'm going to be doing is I need to get this block of bronze down to the nominal size. And again, I'm making 2 of these, and they are basically the same. I believe these original ones here were castings that they made these from, and we're just going to be making them out of bar stock here. So let me grab my calipers. This material is about 1 3/8 in this direction, and it's a little under 1.5 inches on this one. I noticed that Neil's nut is actually a little over 1.5 inches. I'm just going to shoot for 1.5 inches. I don't think that it really matters that much. This is, again, a rough casting, and they didn't even machine the outside stuff to size. I'm going to be machining mine to size, but there's room in there, so it's really not that critical on these dimensions. But we're going to be shooting for 1 3/8 by 1.5 inches, and the material that I have to start with is about 1.6 inches square, a little under 0.6. We got plenty of material to work with. So anyway, let's go over to the milling machine, and got my bronze in here. Got it sitting on a couple parallels. I just want to basically clean the top up. We're going to go all 4 sides and cut it down to size. I'm not really trying to take a whole lot of material off right now. Got a face mill in here. And we're running about 1,000 RPM on that. And I touched off on it. We're just going to take about a 10,000th depth of cut on this. And just take no more than we have to get it cleaned up. I gave a really nice finish there, but left a burr on there, so I'm going to take my little deburring tool here and just kind of break that corner off there on both sides. Let's see here. Rotate this 90 degrees and do it again. So we're about 582 in that direction, about 554 in that direction, so really doesn't matter. I can get my 1.5 inch side off of either face, so let me knock these burrs off again. All right, I need about 85 thousandths off my depth. Let me come back in here and just touch back off on that. We'll just take about a 50 thousandths pass on this first one, get a good measurement, and go from there. See, about 30 thou to get to 1.5 inches, so we'll just go ahead and dial in 30 thou. And come back across. All right, last side here, we're going to inch 375. I got about 175 thou I need to take off of this. So we're just going to do 50 thousandths passes until we get down close. So let's cut her off. So guys, off camera, I went ahead and just milled the tops of these square and got them to length. So basically we're milled on all sides, and just for the record too, the two are a little bit different in length. One of them is just a little bit longer than the other. It probably doesn't matter, but I'm just gonna copy them as close as I can. Next thing I want to do here is lay out the hole, where the hole needs to go through this. And I've done some measuring on this, and it looks to me like the center line of this hole is 1 inch from the top on both of these. And I've spent some time pretty much confirming that. So I'm going to take my dial calipers, I got them set to 1 inch. I've put some die chem on the end of these, and I'm just going to scribe a line across the top that gives me that measurement. And then the next thing I want to do is find the center in this other direction, and let's see where we actually ended up. I wasn't, okay, pretty much right on the money. I was shooting for 1,375, and so let's we want to take half of that value. Half of that value is 0.6875, so roughly about right there on my calipers. And I'm just going to kind of eyeball that there. So we'll come in here, and when I'm doing this, I usually, even though I got it set, I like to run on both sides of it, and that just makes sure that we got the center there. So that's marking where we want to drill our hole. And what I want to do now is come in here, and I'm just putting this up on a bench block, and I'm going to take an optical center punch right here. Now this is an interesting tool. You put it on here, and it's got a little magnifier, and now I can look right down through here. There's actually a crosshair in here, and I can line that right up on that line that I've got there. I pull my magnifier out, and I've got a center punch. I put in here, and that should be right dead center on that mark. And we'll do the same thing on the other one. Okay. Okay. So now what I've got is a little center punch here, and I can use that to indicate on the lathe to get this lined up whenever I'm putting in the 4-jaw chuck, and we'll show you how to do that when we get over there. I'm at the museum today and need to be out here for a while, kind of overseeing a couple of things. And I thought while I had some time, I'd go ahead and just finish this job up out here on the Lodge and Shipley lathe. But anyway, got the part set up. I've got it in my 4-jaw chuck. We took that center punch that we marked before, and what I've got here is I've got the live center on the lathe. I've got a dead center in between it, and I'm indicating off of that dead center. And when you rotate the chuck around, you can see it wobbling. So basically what I'm doing is I'm indicating in the hole, the center punch that we put in there. So that's my high spot. That's the side closest to me, so it needs to go away from me by about 30 thousandths. So I'm going to come over here, I'll loosen this one up. We'll roll that back around, and let's see where we are now. So now we've got it down a little bit tighter. We'll zero on my low on that axis. Come over here. I need to move it in about 5 more thou. All right. Now, let's get it in this direction. So re-zero that one. And I'm going to loosen it just a little bit. We'll roll it around the other side. And I need to take half of that out. Take that out, so we got about 3 thou. I need to take about 1 thou, or 2 thou rather. No, that's 3. You might need to take half of that right there. Just a little bit of wobble there. And we got it within 1/2 thou, so I'm happy with that. Just make sure all these are good and tight. We are nice and centered up on that center punch mark, so we are ready now to go ahead and drill this. Next step, I want to drill this out total to 5/8 diameter. That's going to be my finished hole size, which is kind of the inside diameter of that bore that we need to be threading for the 7/8. So I think that's a 1/4 inch or maybe 3/8 inch drill bit in there, whatever it is. We're going to go ahead and drill through. As you can see, the part is offset. You know, it's kind of like an eccentric, but that center punch hole is right in the middle. That's what's important. So we're going to come in here and drill that through. Let's go ahead and pull this drill bit out. We'll swap it over with my 5/8 inch drill and finish this up. All right, 5/8. We'll just drill it all the way through. There we go. Let me show you my setup here, because this is a little bit different than what I guess I normally do, because we got some unusual things going on here. So first off, we're cutting 7/8 inch 4 left-hand Acme threads internal. So a lot of things going on there. So to make this cut, basically what we'll do is we will feed our bar all the way in, and then we will put our cut in, and it's going to cut coming backwards, coming out, which is going to make it a little bit nicer, because I'm not going to have to be worried about crashing my head in here. I can manually pull it in. That's the nice thing, because sometimes it's hard to see when that boring bar comes out on the inside when you're doing this kind of a setup. But left hand, we're going to be coming out. I want to mention this threading bar that I'm using. I've mentioned this in an odds and ends video, but some of you guys may not be watching that, maybe just watching this series. But this threading bar was actually custom made for this job because it is, again, an oddball size thread, and I needed to have a threading bar that I could come in here with that was a certain diameter. I wanted to have the maximum diameter for strength, and you know, that it would fit up into this hole that I've got, a 5/8 inch hole. So we did some math, calculated what all it would be, and I got in touch with Steve Barton over at Solid Rock Machine Shop. Now Steve's got a YouTube channel. He's up in the Michigan area, and really high quality YouTube channel. I'd really encourage you guys to go take a look at him. Watch the build on this threading bar, if nothing else. And Steve actually makes some boring bars, and that's what kind of got me on this. I had met him out at Texas at the Good of the Land Fest, and we got to talking about some stuff, and ended up, I said, hey, I got to make a threading bar, and one thing led to another, and he offered to actually do this in a collaborative video with me. So he worked on this, actually came up with a design, and then ran into some problems. He talked with Robin Renzetti, who also is another YouTube guy, and Robin really kind of helped him figure some stuff out on this, designed a head to go on this boring bar, and they worked together and made this boring bar for me. So a little bit about it. It's actually made out of solid carbide. Why solid carbide? I'm not cutting with the tool, so I've had some questions about that. Mainly for strength. You know, we're sticking way out here. It's a fairly small diameter, really a smaller diameter for this size cut than what we would normally like to have. So we went with carbide because it's just more rigid, and it's going to be less vibration and everything else. This tool really feels nice when you hold it in your hand. If you ever felt carbide, it's just got a real heavy weight to it. The head on the end of it is actually made out of just, I can't remember what steel it is. It's a certain steel, but it's made where you can take a round piece of, this is actually a carbide insert that's in here that you can grind, and Steve actually ground me a couple of extras in case we have a slip up and break one or whatever, but this went ahead and did that. So on Acme threads, you basically have to create a grind specific for the pitch that you're doing. So every pitch has a different grind. Here's a thread pitch. This is 4 threads per inch, and you can see that, you know, this is just a perfect fit in there. But if you go to a higher or lower pitch, I'll just pull the next one out in the leaf. This is a 3.5 pitch. You can see that, you know, it doesn't fit. So unlike a 60-degree thread, an Acme thread, you got to have the profile for the thread pitch that you're cutting, and that's what we've got here. Because of the small diameter, this thing is also kind of twisted a little bit to take care of helix angles and stuff in there. If you think about it, that thread cut that you're cutting isn't straight up and down, it's actually at a little bit of an angle, so that's taken into account for that 4 pitch, and that's actually been already put in here when I got it. If I have to change it, I'm going to have to take real care to get that angle just right. But anyway, I want to thank Steve over at Solid Rock Machine Shop for doing this. This thing is awesome, and what's really nice about this threading bar is with this head on it that Robin Renzetti designed, and it's just silver soldered on here, but I can loosen this out. I can put in different cutters for different jobs down the road, so it's not a dedicated bar. So anyway, a little bit about that, and again, go take a look at Steve's website or Steve's YouTube channel, and I'll put some links in the description on this video to the build on this because it's worth watching. I don't have a whole lot of clearance going in, and I want to make sure that I go back to the same spot every time to feed my bar in, which is why I have an indicator in the back. So basically, whenever I come out of my cut, I can just watch this indicator, and it's going to make 1 revolution on it. When it goes to 0, I know that I've got clearance, and my cutter will go through the hole, okay? And then I will bring it back down to 0 on my dial down here below, just like I normally do, and I'll be feeding the cut in using the compound. And I'll be watching that on this indicator. So I got 2 indicators. One is clearance going in. This indicator is going to tell me my depth of cut. Note, because this is Acme thread and it's left hand, I have my compound turned opposite from normal. You want to be cutting on this front thread here, so when we move our compound, it's going to be pulling it in at that angle. So this is a 30-degree angle altogether, the double angle. So half of that's going to be 14.5 degrees, which is what I have my compound set to. The depth of cut on this, according to the book and everything, is going to be 125 thousandths of an inch. So we got 4 threads per inch. 4 threads per inch is 250 thousandths, quarter of an inch. And then half of that's going to be the depth of cut. So again, 1/8 of an inch, or 125 thousandths. That's what I'll be watching on my indicator. Now bear in mind that I've got the lead screw that goes in here. So this is just a guide. This is not absolute. We're going to make the lead screw fit. So when I get close to 125, we're probably going to stop. We'll start doing test fits, because I'm going for a fit here rather than maybe something just right out of the book. What's more important is this thing works properly. And my lead screw, quite honestly, has probably got a little bit of wear in it. So we may have to be off of that 125 here. I think we are ready to go. So what we'll do is we'll go ahead and fire the lathe up. I got my speed slowed down. I've already checked my threads per inch. You know, I always do that, but we're on 4 threads per inch. I've got it in left-hand mode. We'll bring the boring bar all the way in. I'm going to take about a 5/1000 depth of cut, which I'm watching on this indicator right here. I'm not worried about the one in the back anymore. We'll wait for our thread dial to come around, and we'll let it feed out right here. And there's our first pass. So now I'm going to watch this indicator in the back again. I'm going to take it back to 0. That should give me my clearance to come back into the hole. We'll go to depth. I'll 0 this now on the cross slide. I'm not worried about this indicator or this indicator. And I'm going to go ahead and feed in another 5 thou, and we'll feed out. All right. Rinse and repeat. Back to 0 on the back indicator. Go in to depth. 0 on the cross slide. 5 more thou. I'm cutting bronze, so I'm going to make a 5/1000 cut pretty much every pass. And that should be just fine. right, we're going to dial in here. That's going to be 100 thousandths total depth so far. We've still got about 25 more to go. Let's wait for our threading dial to come around. And we'll dial out. Here we go. I think we got a fit here, guys. I'll take my rod here, my lead screw, and it is threading in nicely, trying to stay out of y'all's way on that camera. But all in all, that looks good. Not quite all the way through, but I've already tested it. We've got really no end-to-end play. There is just a little bit of extra moving around in there, but that's actually going to help me with alignment. Main thing is I don't have any of that end-to-end play, so I won't have any of that backlash in this new nut here when we get it back on there. So this is ready. I'm going to take it all off. We're going to go back to the shop this evening at my house and go ahead and finish cutting this part out. Well, guys, I think that's going to be a wrap on this one. We have got our nice Acme threads all machined through the block here. Everything feels good, looks good, and I think we're going to go ahead and finish this part out by milling in everything and doing the drill, drilling the holes. That's going to be a separate video. We're just running out of time on this one. But I do want to make sure, once again, I give a big thank you out there to Steve Barton over at the Solid Rock Machine Shop for helping with the special threading bar, as well as Robin Renzetti for his contributions in that as well. If it hadn't been for those guys, you know, we may have gotten this job done, but it'd have been a heck of a lot more work. They really helped me out a lot with the design and getting that custom threading bar made. And I promise you, the one that he built was going to be a lot better than the one I was going to build, which is going to be made out of a regular piece of steel and probably have a square hole broached through there. I was really concerned with the length and the diameter that I was going to be getting an awful lot of flexing on that bar had I gone with the design that I was looking at building. But putting that solid carbide in there really made the difference in making that bar rigid, and everything worked really, really well. So again, thank you, Steve, for that. And that'll be it. As always, guys, thanks for watching. Leave me a thumbs up if you like what you see. Comments are always welcome, and please subscribe to the channel if you haven't already. We'll catch you next time around. Thanks for watching.